A bar graph is just a graph that has each category of data represented and labeled, usually on the horizontal axis, and the frequencies or the relative frequencies are on the other axis. Sometimes you see sideways bar graphs, but in this course, most of the time, you'll see your categories with the labels on the horizontal axis and the frequencies being on the vertical axis. We draw rectangles of equal width for each category. The height of each rectangle represents the category's frequency or its relative frequency. And we have a slightly different type of graph called a Pareto chart. It's just a bar graph where we draw the bars in decreasing order of frequency. In other words, the category with the highest frequency is going to be on the left, and it's going to decrease down to the category with the lowest frequency, which will be on the right end of the graph. Here's an example. We're going to use our M&M data to construct 3 different graphs: a frequency bar graph, a relative frequency bar graph, and a Pareto chart. Here's the information that we have. The categories, which are the colors. We have the frequencies, the relative frequencies, and the percentage frequencies. First, to do our frequency bar graph, all we need is the colors and the frequencies. Here's our frequency bar graph. Notice we just have a bar or rectangle for each color. They're labeled down on the horizontal axis, and then the heights of each bar tells us the frequency for that category. Looking at this graph, we could see that there must have been 5 green M&Ms because the height of this rectangle is 5. Now for our relative frequency bar graph, here are our colors and our relative frequencies, and here's our graph. The only real difference between this and our frequency bar graph is what happens on the vertical axis. Here we have relative frequencies, so we have decimal values instead of the actual frequencies or counts for the categories. For our red category, we can see that the height of this bar goes up to about 0.2. Now finally, we'll look at a Pareto chart. For a Pareto chart, you can use frequencies, relative frequencies, or percentage frequencies. I just did this one with the percentage frequencies because we had already used the other 2. And our Pareto chart lists the highest frequency category first on the left and then goes in decreasing order. So the lowest frequency category will be the furthest one on the right. This goes from brown, which had the highest frequency, down to blue, which had the lowest frequency. Now, one place that we can use relative frequency distributions or relative frequency graphs is if we're comparing 2 data sets, especially if the 2 data sets have different total frequencies. Here's a case. We have data for 2 different years, 1990 and 2006, representing the marital status of U.S. residents 18 years of age or older. And the reason that we would use relative frequencies here is we're going to have different totals. In order to draw a relative frequency bar graph of this data, we need our relative frequencies. The relative frequencies gives us a different picture of our 2 distributions. Now we're ready to draw our side-by-side bar graph. Here's the data that we need. We have just the percentages for 1990 and 2006 for our different categories. And here's our bar graph. And this really shows what is happening between 1990 and 2006. This is talking about the percentage of the total. So the never married, you can see the percentage increased. For married, the percentage decreased. For widowed, it decreased. For divorced, it increased. A pie chart is just a circle that's divided into sectors or slices. Each sector represents a different category of the data, and the area of each sector or slice is proportional to the frequency of the category. Here's an example of constructing a pie chart. We're going back to our data about marital status for U.S. residents, and for pie charts we need relative frequencies because we need to know the proportions to figure out how big to make our different slices. We're just doing this for 2006, so here are the relative frequencies for 2006, and then our pie chart gives the percentages for each category. Now sometimes you'll see pie charts with the counts included, which is fine, but you do have to have the relative frequencies in order to actually figure out the size for each slice. Here are our data labels over here. One thing that's interesting in this pie chart is if you compare the relative frequencies over here, which were rounded to the nearest tenth of a percent, these frequencies are rounded to the nearest percent. Notice that all of these got rounded down except for this one, which got rounded up to 11%. Now the reason for that is that whoever constructed this pie chart wanted the total of these percentages to come out to be 100%. With rounding error, if this had been rounded down as it really should be to 10%, then these percentages would have added up to 99%. The reason they rounded that one up is that it was the one that had the highest value in the tenths place of any of these. So it's the one that made sense to round up instead of rounding down.
One really important point about statistical graphs is that they give us a way to see the important features in the data besides just looking at a table full of numbers. For example, with this pie chart, for most people it would be easy to look at it and see at a glance that the biggest category is the married category and the smallest is the widowed category. For most people it would be easier to see that in the pie chart than to look at the frequency distribution table and pick out those points. If we're creating our own statistical graphs, it's easy to tailor them so that they emphasize the important features that we want to point out to our audience.